Okay, the other topics that we looked at today is divide and conquer. Okay, so the idea of divide and conquer is pretty simple. Okay, let me try to explain that in picture first. Okay, suppose this is the problem that we would like to solve. One way to think about solving the problem is that this is a big piece of cake, and you would like to sort of like eat the whole piece, right? One way to eat the whole piece of cake is like you just keep eating it from one way or another, right? Until finally you eat the whole cake. Okay. To do that in many ways, you think about sorting. Um, if you do selection sort or merge or insertion sort, you have an array, right? And you try to sort of like make sure like this part of the array is sorted and keep, increase the size of the sorted part. And this is like eating a cake one bite at a time, right? However, in divide and conquer, you're not doing that. Do you try to speed up the way you eat a cake? So you basically, instead of eating a cake one by one, you cut a cake into two pieces, right? Cut them, and then you somehow find a way to now you have two pieces of cakes. Okay. And then since they are all both cakes, you try to eat them, right? The way you eat them is like you recursively do the same thing, right? So you cut a cake into two pieces and then try to work on it recursively. Okay, when you recurse on that, you basically divide the thing into two pieces of cake, and then like here as well. Okay, so this is like merge sort. Okay, so you start with a list of numbers, then you divide into two pieces, right? And then you recursively sort it. Okay, to sort that, you divide into smaller pieces. Okay, and then you try to sort it and divide it and so on. So you have a recursion. Okay, and then this is the way you do that with divide and conquer. Okay, when we talked about sorting, you have been writing merge sort already, so you sort of have some idea on how to do divide and conquer. In this today we're gonna look at other tasks on divide and conquer. Okay, but to write implement divide and conquer algorithms correctly, you need to use recursion. So the first few tasks that I asked you to do is to just write a simple program to do a simple thing like finding the maximum of a list using recursion. I also provide you with the template here. So the first task is like find the maximum of the list or some list. Okay, I have a template and a list class for you. So your procedure is to basically to implement something, right, recursively. Don't do that using a for loop or while loop, but write recursively. Okay, so to find the sum of the element in the list, you basically check if the list is empty, and if it's empty, you do something. Otherwise, you do find the list sum of the ended part of the list. Like, so let me try to explain a little bit. Okay, so you have a list of integer, right? 10, 2, 5, 6. You want to sum the numbers on the list. Okay, so you check if the list is empty. If it's empty, then it should be 0, right? Otherwise, you basically recursively think about this. So the sum of the whole list is this part of the sum, is this the sum of this part of the list and this number 10, right? So you basically add 10 plus something, right? But this is also a list, so you can recursively call this sum on that part of the list, right? So that's the idea. So the first part of the practice is just to write recursive functions. Okay, the other part is basically most of the divide and conquer tasks that we have is going to based on binary search. So the idea of binary search is simple. So you have a list of numbers sorted, okay? They are sorted. And you would like to find one number in it, okay? So the idea is that you basically want to look at the middle guy. And from this, you can infer, so you want to find x, right? And you look at the middle. So you have a list A, from A0 up to A, say, n-1. Okay, you look at the middle guy, and if the middle guy is larger than x, then you know that x is going to be here. If the middle guy is smaller than x, then you know that x is going to be here. If it's equals to x, then you know exactly where it is, right? So you can write a simple subroutine for binary search. You can write that recursively, or you can write a while loop for it, okay? So let me show you how to write it using a while loop later on today, okay? So, but this approach can be used to solve many other problems, okay? So let's take a look at one of the problem in the problem set before going to the implementation of binary search. So we will look at what's the marble. This is the problem that we will try to implement binary search. But let's look at this fill the container problem. Before you continue with this video, maybe you wanna take a look at to read it a little bit, okay? Okay, so let's look at the task and try to read it before continuing with the video, okay? So please pause a little bit and read the task statement for now. All right, so you have a containers and you have m of them. You know that you want m of them, right? And then you have a bunch of vessels, okay? So this is places where you have milk, okay? You would like to pour a milk from the vessel to the container, right? When you pour it into one of the container, so you have to pour it from left to right. So the first one go to the first container, the second one go to the first container, for example. If the container is not full, okay. And then after the container is full, or maybe the third vessel contain too much milk, you need to pour it to the next container, okay? So basically, if you know the amount of milk for each vessel, okay, but you don't know the size of the container, okay. But if you say the container is of size, can contain milk of size, say L. Let's say they all can contain the milk of size L. You can pretty much simulate the procedure for pouring milk into the container and figure out how many containers that you need so that you can pour all the milk, okay? All right, but this is not the task that you would like to solve. You would like to find the minimum L so that if you have M containers, you can pour all the milk into it, okay? So if you know L, you can figure out the number of containers. But if you don't, but the problem is that you know the number of containers, you like to find the maximum, the minimum value of L, okay? To do that, please think about it, okay? I'll give hints in class, but the idea is that you do some way or another. So if you want to brute force on it, so we could try all value of L, right? So in type value of L to be 1, 2, 3, 4, and so on. When L is 1, you might not be able to pour the milk at all, right? Right, because the first vessel has to go to some of the milk. So at some point, the minimum size of the container has to be at least the maximum size of the milk in the vessel. But if you increase the value of L, the number of containers that you need decrease, right? So you can brute force on that, okay? And then you get things done, right? But that would be really slow. But the value of L that you try, okay, it's going to be something large. At the end, it's going to be something large. It's between some number and some number L, big L, okay? So with this idea, you can somehow do the binary search. So you guess the value of L and do the binary search to figure out if the value of L, let's say you guess A, let's try L equals A, and you can say L is large, A is too large or too small from that, and then you figure out, okay? So this is the hint of one of the tasks. The other task has the same idea. The Angry Birds and bitmaps. Bitmap is basically recursive problems. You can implement it. Okay. So grep Y, I will give hints in class. Okay. Okay. So now let's try to work on where is the marble. So in this task, also let me explain the task for you. Okay. So that we can proceed with the implementation. So you have so there's a game. Okay, so the input contain many test cases. For each case, at most 65 test cases. Okay, for each case, you have N and Q. N is the number of marbles. Q is the number of questions, the queries. Okay, the number of okay, then the next N line contains the number on the marbles. Okay, after you get the marbles, you sort them, and for each query, so if you look at this, the first 4 number is the marble. Okay, and that's one queries, 5 here. Okay, so you take the marbles and sort them, and the query say, what's this, the first position of 5. Okay, so let's look at one example, this example in detail. So you have the marbles to be 2, 3, 5, 1, and you sort them, you get 1, 2, 3, 5. The question is 5, so the position of 5 is the 4th position. So they say you found it. Okay. Another example is this: you have 5 marbles, and then the query is 2 and 3. Okay, so 5 marble, 1, 5, 1, 3, 3, 3, 1. You sort them, 1, 1, 3, 3, 3. The first question is 2. There's no marble there, and you say not found. And the second question is 3. So the first one is here, so you should answer 3. That's the problem. Okay. So the idea is that we're gonna read the input, the marbles, and we're gonna sort them. Okay. When the query comes, you do the binary search. You would like to find 2 or 3 in that, right? So you basically do the binary search. I'm gonna show you how to implement binary search, but there's a catch. Okay, so if you find 3 here, you want to search for 3, but maybe you found 3 somewhere else, but that's not the first place you see 3, right? So you need to be really careful a little bit on how to implement the binary search so that you find the first number in the array, right? Okay, so let's try to implement it. Okay, so so let's read the input first. Okay, so so if N and Q is 0, then you just quit, right? Okay, otherwise you're gonna read the first N numbers, and then you're gonna read Q questions. I'm gonna keep the marbles inside the vector. Okay, so I need to clear it, marbles dot clear, and then I'm gonna read the marble. Okay, so let's say, oh, it's give me pretty nice autocomplete C in X, and then say marbles push back X. Okay, gonna read all the marbles, put it in the array, and then I'm gonna sort it. Okay, sort marble. Oh, and then to do binary search, I need to sort, right? So I need to include algorithms. Now I'm gonna sort the marbles. Begin and marble. Okay, so that's, now I'm done, right? Now I need to read the queries. Oh, this is pretty amazing. I'm gonna read Y, scene Y. Then I'm gonna find the position of the marbles. Okay, so all right, so let's write a function that do the binary search for us. Okay, so we just output cout. Let's declare a function first. Int if you don't find a thing, just output -1. So let's call binary bin search. Okay, and then just put the value Y. Okay, we're gonna come back and write bin search. Okay, so I'm gonna write cout bin search Y and now. Okay, so that's my code basically. So let's do the binary search. Okay, so to do binary search, you need to do two things. Let's see how this guy would, C-Leon would do my auto completion. So I have left and right. Okay, so left is gonna be so I'm gonna maintain two indices that are the value of the thing that I have. So I'm gonna have left to be 0 and right to be marble.size, so it's going to be n-1. Okay, and then my loop is going to be basically this, while right is at least left is less than or equal to right. Okay, all right, so let's compute the middle guy, the index of the middle guy. So mid is going to be left plus right over 2. Okay, now I'm going to check. Oh, okay, so this is interesting. If it's equal to Y, then I should be done, right? So let's write the binary search version where when I find the thing, I just output the index. So I just return mid. Okay, otherwise if marble.mid is less than Y. So now I need to switch to the middle guy is too small. So I say mid, so I move the left to be mid -1. Otherwise I say right equal mid -1. Okay, so this is my code. And if I end up here, I don't find the value of the thing that I'm looking for. So that's the -1 that I have. Okay, so this should do something, right? But it won't be correct. But let's try to run it a little bit. Okay, let's see if it works. Okay, so let's say 5 marbles, 2 questions. Let's say 1, 2, 4, 3, 10. Okay, so let's ask the question that for something that's not on the list. Say 7. It should answer -1. Okay, right. So how about 3? It should answer 2, right? I'm off by 1 here. I just returned the exact index, right? But the task asked me to return the index in the task statement start with 1. If you look at this, so it start with 1, but in my code I start with my index start with 0, so I need to add 1 here. But it should work now. Okay, so let's run it one more time. Am I done? Should be done. How many questions did I have? Oh, no. I need to put one. So let's break. Let's stop it. Okay. All right. So it should work now. But the problem is if I have too many numbers. So let's run it again. If I have duplicates, let's say 5 and 2, and then I have 1, 3, 3, 3, 1, and I ask for 2. Oh, okay. So I should return -1, right? But let's fix that later on. Let's fix the format later on. But if I ask for 3, it should return 3, right? But actually it's on the let's do it again. It's correct, but it's excellently correct. So let's say if everything is 3, if I ask for 3, it should return 1, right? So all my marbles is number 3. I ask for 3, it should return 1, but it returned 3 because in our binary search, the first time I see 3, I just answer. Okay, so that's the thing. Okay, so let's see the problem here. So if I have say 3, 3, 3, 3, 3. When I do the binary search, I look at the middle guy, right? I'm looking for 3, and then I see 3 here, so I just output 3. So that's not correct in this case, right? So if I find 3, then I should basically, I shouldn't stop there, right? I should try to find 3 somewhere for maybe on the left first, right? So the way I'm gonna fix my binary search is kind of like crazy, but we can do that. Okay, so this code might not just work, right? You need to fix the format, the output format first before you can use it. But let me try to fix the logic here first. So if so let's deal with the case when my guess is too large first. That's the easy part. So okay, so if marble, so let me try to work on it again. Okay, so if marble's mid, okay, it's less than y. If my guess is too small, I would just do this. Okay, but if it's too large, and also if it's not just too large, but this contain the case both marble mid is too large and equal to y. So this is the case when marbles is a little bit too large. I'm gonna move my right to the first to the mid as well. So let's look at this. So if I see this, so in the beginning my left is here and my right is here, right? So if I find 3, I move my right here. Okay, and in the end my 2 pointer left and right would end up something like left, right, and left. Okay, and in this case I would end up having so the left pointer is gonna be, if the left pointer is the value of the thing that I have, okay, then I know that I find the answer. Okay, you can check this logic. Okay, so if I have so the idea is that if my target is around here, when I put when mid is here, I usually put my right in here, right? So in the end, if mid is here, I put my left in here, right? So in the end, the left pointer is gonna point to the first guy, and the right pointer is gonna point to somewhere else. So if you do this at the end, okay, at the end, you can check the left pointers, okay? So basically, if marble left equals to y, you just return left. Otherwise, you just return -1, okay? Not found, okay? So let's see if it works. So let's try to run it again. Okay, it seemed to be working, right? So 4 doesn't find. Okay, so that's how you write binary search, and with some extension on how to deal with the case when you would like to find the first index. So the code looks pretty much like this. You should be able to write binary search, the normal version, and this is the more the modified version that deal with finding the first guy that match as well. Okay. All right. So I think you're ready to work on the problem set. Good luck. And if you have questions, just ask me or the TA. All right. See you.